Sagemaker workflow steps module and importing the processing step, then we are ready to define a processing step, which takes as one of its parameters indeed the sklearn processor object, plus the configuration of inputs and outputs, and well, the arguments. Another important parameter for sure is our code, so the actual processing code, which is defined here, which points to a processing script, which I'm not going to dive deep into, but as you can imagine, this is a standard sklearn processing code which does the feature engineering operations, the split, and well, saves the sklearn model. Great. Once we have defined our processing step, please note that here is just metadata. We are not running anything. We are building our workflow. We can now move to defining the training step. Also for training, it's a similar thing. We can use the standard XGBoost estimator class and configure the class as we would do even when running standard XGBoost training from Sagemaker. We pass the collection of hyperparameters whose values are set to the parameters the workflow parameters, the pipelines parameters that we have defined, and plus we set all the standard parameters for running training in Sagemaker, like instance types, instance count, framework version, and so on. Great. Once the estimator is defined, well, one of its parameters is also the code location, so the entry point. So what is the actual code that we want to run? And again, here I'm not going to spend too much time on this, but it's training an XGBoost model and saving the model to the output folder. And yeah, that's once we have it, once we have the estimator ready, we can create a training step. So similarly to what we have seen for processing, we can do for training. And we have a training step which takes as parameters the estimator itself. So again, you can see how easy it is converting the code that, well, would be executed outside of a workflow into a step. So you actually wrap that code with a step. And again, you pass as inputs here the location of the training and validation data. And as you can see here, we are setting it to the outputs of the previous steps of the processing step. That's a very convenient way of configuring our workflow. And the Sagemaker pipelines will also automatically understand the dependencies between the various steps based on the inputs and outputs that we actually specify. This is important because, it allows you not to set dependencies explicitly, but in case it is required, you also have parameters to control that. Great, we have our training step ready. Now we can define the step to register our models in the model registry. As I said, we need first to combine the two models into an inference pipeline, and then we will register this kind of combined model in the model registry. To do that, we just define two standard model objects in Sagemaker. So the sklearn model, which takes as model data, as location of the model, the output of a processing step, so the where the processing step has saved our model, plus a few other parameters to customize the inference logic, which we're not going to focus on in this demo. And the XGBoost model similarly defined, where the model data is set to the outputs of the training step, so to the output location of the model from the training step. Then we combine the two models in the so-called pipeline model, which is the serial sequence of the two. And finally, we are ready to register the two models to define, the register model step that will register the two models in the model registry. This is the register model step definition, which again takes as input a model object. So it's very easy, plus a few other parameters as well to define the supported content types and response types and default instances for real-time inference or batch inference. Well, all the metadata that you would expect to store in the model registry. Well, once we have the register model step, we are now ready. We have the processing step, we have the training step, we have the register model step. We can define the pipeline, the entire pipeline. We do this creating a pipeline object. We need to set a pipeline name, which is end-to-end ML Sagemaker pipeline. We set all the parameters. We set the collection of the step processing, training, and register model. And as I said, the dependencies will be computed automatically. And well, that's it. We can also take a look at the definition of the pipeline if needed. This is indeed a JSON, but again, we don't have to edit this JSON manually. It's the SDK that is generating it for us. And great. We can now insert the pipeline definition, so it's saved to SageMaker, and we can start it. For example, I can trigger another run of the pipeline. Although this notebook was pre-executed, now I'm triggering another run of the pipeline. So you can easily see that, this is a pipeline that has been committed to SageMaker. So the definition, the metadata, and all the definition of the pipeline is saved. And now we are triggering it with this API call. But this API call now is executed from the notebook just for the purpose of this example. But you can run the pipeline from, elsewhere. It's just an API call. Indeed, how we can monitor the executions of the pipelines. Now, there's this nice tab here, SageMaker Resources, where you can find pipelines here, and then you will see the list of all the pipelines that you have executed. And we have this one with last modified 56 seconds ago, which is our pipeline. If I click on it, I can access this screen where I can see the list of all the past executions. I can see the definition of the pipeline, this nice visualization, and I can also look at all the default parameters, so the supported parameters with the default value for the pipelines, plus a few other settings. I can also download the pipeline definition, so this is the JSON that we had inserted few seconds ago. And another interesting aspect is that I can start an execution of the pipeline. So once the definition has been committed, you can start an execution of the pipeline, providing the various parameters that we had defined. And you can also monitor the execution of an existing pipeline. Let's take one run that already succeeded, which is this one. As you can see, there's a processing step, processing operation, training operation, and when you click on the specific step, you can interactively check the input configuration, the output configuration for the step, all the logs. So these are the logs that are emitted by SageMaker processing, and a similar thing you can do for training, inputs, outputs, logs, and so on. Once we have done this, we can now move to the to SageMaker projects. So what SageMaker projects allows to do is to introduce machine learning CI/CD. So far we have automated the machine learning workflow, but we haven't been doing machine learning CI/CD. We have just the orchestrator. Now, how can we introduce machine learning CI/CD in an easy way? So what we have done with SageMaker projects, we have made available to our customers a series of MLOps templates, which once selected and once provisioned, will create all the required resources to implement machine learning CI/CD with either the AWS tools for CI/CD, like AWS Code Pipeline, Code Commit for the repositories, and Code Build for the build actions in the pipeline, or with third-party tools like Jenkins and third-party Git repositories like GitHub, for example. But in case these default templates that we have provided are not enough for your specific use case, because you might want to, I don't know, use other tools that you already use in the company, and you don't want to re-implement or use different tools for CI/CD, you have the chance to create custom templates, custom project templates, which will allow you to, integrate your tools with Sagemaker, within Sagemaker. So you, as a DevOps, you will define the, let's say, the template. The template is defined via AWS Service Catalog as an AWS Service Catalog product, and technically speaking, is a cloud formation that deploys your infrastructure for CI/CD. And then you can associate the template to Sagemaker Studio, and it will appear, let's say, here in the organizational templates, which are not, let's say, the default templates provided by AWS, but are your company templates. And this is pretty convenient way also, again, to integrate your own tools. And while still giving, users and data scientists a self-service functionality to set up a machine learning project. What this means is that when you create a project from Sagemaker, you typically have to deploy, the code repositories, the associated CI/CD pipelines, the triggers, and maybe some resources like default buckets where data is going to be saved, or maybe the model package group in the AWS model registry, which is what we do with the default templates. For example, the template that we are going to use today is the MLOps template for model building, training, and deployment. This template provisions two repositories, one for model build, the other one is for model deployment, which have two associated CI/CD pipelines. The CI/CD pipelines for the model build repository takes care of pulling the source, and then in a build step, it will execute a Sagemaker pipeline, a workflow to build the model and register in the model registry, versus the CI/CD pipeline for the model deploy will take a model from the model registry, deploy to a staging environment, run some tests, wait for a manual approval, and then promote the model to production. There is this pipeline is also triggered by another event that is the approval of the model in the model registry. So if you change the model approval status in the model registry, the deployment pipeline will be triggered. Let's take a look at the resources that are provisioned as part of that project. You can see here what I was saying. There is a model build repository, a model deploy repository. Then there is there are two pipelines, the model build pipeline and the model deploy pipeline, which does the actions that I was mentioning. So deploying to staging, running some testing, and deploying then to production after a manual approval. Now, how do you create this project from Sagemaker Studio? It's very easy. You select this project template, and then you just add the name, and it will create these resources for you. But for the purpose of this demo, we have already this project deployed with the repositories that we have seen right now on code pipeline. So we don't want to wait for the resource provisioning time. Great. Let's see what is in these repositories that are created automatically by Sagemaker projects. So I have created this project, and I have cloned the repositories here, the model build and the model deploy. In the model build one, there is also some seed code, which allows us to define a pipeline, a workflow, a Sagemaker pipeline. And this seed code also defines a build spec.yaml file, which instructs AWS code build on what to do in the build stage. Specifically here, this build spec, I can show it to you, is running the pipeline. So this means that as a default trigger, every time I will commit a change to this repository, we will trigger the code pipeline that will pull the code and execute the workflow. That's what the default template does. Now, let's try to apply a change. I've already copied my pipeline here. It's the same pipeline that we have defined in the notebook, as you can see. has been defined here as a Python module, as a Python package. And well, what I can do is I can change some code, AI, ML, innovate, EMEA. I can change some code here. It's just a very basic change just to trigger the execution of the pipeline. And then we can commit these changes, demo changes. I save it, I commit, and then I push these changes. And what we should expect is that the associated pipeline gets executed automatically. Let's go to code pipeline again. And indeed, as you can see, the model build CI/CD pipelines has been executed. Now is in the model, so in the source stage where it's pulling the sources. Then it will move to the build stage, actually already moved to the build stage, which is where the build spec will be interpreted and the Sagemaker pipeline will be executed. Let's see if this is happening already. If we go back to the project, we also have in this screen all the resources associated, including the pipelines. This is the pipeline that we have defined. These are the past execution, and shortly we should see a new execution appearing, which is the execution that was triggered via code pipeline. Great. Now, while we wait for the triggering of this execution, let's see what is in the model deployment repository. In the model deployment repository, we have the seed code for model deployment, which includes some tests that you can run, some example tests that you can customize and run, but also build spec and the endpoint configuration. The reason for this code is that, well, it basically defines how we want to deploy our model to the endpoint. So every time we change this repository, the last approved version of a model in the model registry will be moved to the staging environment, but also the same pipeline will be executed when we manually approve a model version in the model registry. Now, I don't want to focus too much on this code. In the meantime, as we can see, the pipeline execution was triggered, but I just want to show how that pipeline gets triggered as soon as we change the status of a model version in the model registry. Indeed, if we go to the model groups, so from the project screen, I can also get access to the associated model registry. I can go here. There are two models that have been already approved, and there is one model version that was not approved, let's say, by the data scientist. I can approve the status, and what we expect here, okay, approve. And what we expect here is that when I approve the status, I should be triggering the associated model deployment code pipeline. Let's go to code pipeline. Indeed, the model deployment pipeline is in progress. It's in progress, it's getting the sources, is now in the build stage where it is building the CloudFormation templates to deploy that model version to the Sagemaker endpoint. After it builds the CloudFormation templates, it will run the deploy action, and then it will wait for a manual approval to deploy to production. Let's wait a few seconds. How we can realize that we are deploying the model to a real-time endpoint? We can go to Sagemaker, and we have our endpoints here. The two endpoints we are referring to are, this one is the production one, this one is the staging one. Since they are already running, the default template is able to update the model to the endpoint. So it will update the endpoint with the new model version that we have approved. So as soon as as the build stage is executed and moves to the deploy staging, we should see the staging endpoint in updating status, which means that the new model version is passed to the endpoint, is going to be updated. Let's wait for a few seconds. Yes, now we are in the deploy staging state, and we should see shortly that that endpoint, yeah, it's in updating stages, because what we have done, just to conclude, is we have approved the model in the model registry. There is an associated trigger that updates, that triggers the AWS code pipeline for model deployment, which then updates the staging endpoint. Now it will also, after updating the endpoint, run some tests as defined in the test folder here, and then it will wait for a manual approval, which could be by the folks in your company who take care of managing the approval to production, and then approve to production, so update the production endpoint. So this concludes our demo for today. So we have seen how to orchestrate the machine learning workflow, how to use the model registry to store the model versions, and then how to introduce